Right. So in my previous lecture, I discussed about error detection techniques. Right. Now today we'll talk about something different activities which are part of testing. So the first activity that you can see here is test suite design. So very first we need to design our test cases. That means the set of test cases using which a program is to be tested is designed possibly using several test case design techniques. So by using some design technique, test case design techniques, we'll try to come up with the test cases, and those test cases will be applied to the software which is is part of your system testing, right? So running test cases and checking the results to detect failures, right? So then the second activity that we will do is we'll execute those test cases, and then we will try to check whether the results that we are getting as expected or not, or is there any failures. If at all any failures is there, so then those things will be recorded down. Okay, so each test case is run and the results are compared with the expected results. Now the test cases for which the system fails are noted down for later debugging, right? So for the test cases, whatever the for whatever the test cases the system fails, so those test cases will be noted down, and later during debugging we'll try to debug those errors. That means we try to locate those errors. Okay, what are the reasons behind that failure? So we'll try to find out during debugging. Now then, that is what exactly locate error. So the failure symptoms are analyzed to locate the errors, right? The statements that are in error are identified during locate error. So we try to where that particular error is. So based upon the symptoms, whatever the failure symptoms, so based upon that we try to locate the errors. And then error correction. Once you identified those errors, right? Once you identified those errors, now you try to correct those errors. That is what we try to do. So as part of this testing process, so initially what you do here is first we come up with the SRS document, right? And then we create the design document, and then you have a coding document, right? So all of these things are ready, then only we start our test case. We try to design the test suite, right? That means we try to create the test cases, right? So once code and design document and SRS everything is ready, then only we go for the test cases, right? So that means we go through this design test suite, right? And then you design that test suite. Once it has been done, then ultimately you get the test suite, right? And then once this test suite is ready, then you run those test cases and then check the result. Okay, if at all any failure are there, so failure list will be noted down, right? So wherever that particular failures, whatever the failures that you have seen, that has been noted down, and then you try to during debug the program, what you try to do is you try to locate those errors, where those errors are, right? And then you make a list of those errors, right? And once you found the once you have this list of errors, then you try to correct them one by one. Okay, so ultimately at the end you will be getting a corrected program. So this is what these are the basically this is the way that we try to carry out our testing. Now then, why we try to design these test cases? Why not be sufficient to test a software using a large number of random input value? Why design test cases? So very first yesterday also, I told you this, right? So why don't you go with a very large set of random input value, and then why you go with that? Why is not that sufficient? What is the reason behind this? As a result, you go for the test cases. I told you with an example right? So because the domain input is very large, so when you pick some of these test cases or the input random input values, so maybe they may not be a belonging to all sort of different characteristics available within the data, right? So I told you, right? So that is the reason why you need to go with some test cases, and those test cases will be the representative for whole domain data. There are some input data which are very similar. Okay, that means those data, yeah, so if you giving two input data, if when you give those two input data, if they are going through, they are checking only certain portion of the code only, right? So then I think I mean that is not enough, right? So we need to have the set of input values in such a way that it should cover all of the program codes. It should test all of the decisions, right? So that is what, right? So when test cases are designed based on random input data, many of the test cases do not contribute to significance of the test suite, right? So randomly when you take, usually so even if you have many input data, still they will not significantly contribute towards a particular test suite which is really required to be tested. Okay, so we'll come to that, then later on, maybe in one or two example, maybe we'll be going through different tests, testing techniques, then you will be able to understand if you do not understand as of now this. So they do not help detect any additional defects not already being detected by other test cases in the soup. Okay, so that means whenever you give some input data, right? So you should whenever you give some input data, that input data should detect some defect. Okay, it should detect some defect, right? Now if you giving 10 set of input data, but those all 10 different input data is detecting the same, let's say same error, okay, defect, then there is no point in going with all those 10 input data. You can take only one input data which can detect that particular defect, right? Now, if you have input data, another input data, but if that input data is detecting an additional defect, then it is useful, right? So that means you need to pick the input data in such a way that so they should identify or they should detect all of the defects that are there within a particular software. Okay, so this is what we try to say. Even if you going through a large input in a domain, large random input values, if they are only covering only 5 defects out of 10 defects that are there in the system, then I mean no use. But you can take only few input value in such a way that they all detect all 10 defects. That is what our objective. So you need to have a test suite. That means that the test case will contain the test cases in such a way that it can detect almost all the defects with less number of test cases. That is what our objective, right? So testing a software using large collection of randomly selected test cases does not guarantee that all of the errors in the system will be uncovered. Okay, so if you say if I can take some randomly, even the randomly whatever we have selected the test cases, if they are large also, so still it cannot ensure that or we cannot guarantee that always the system will be error free. That is what we say. Now here we can see one case study that you can understand. So whatever I said in the past, so you will be able to understand this. Now if you, let's say here is the program, if x is greater than 10, then max is equal to x, else max is equal to x. Okay, that means I mean if x value is greater than y, then the max is always x. Okay, so even else part, you see max is equal to x only. That means here is the error we have. Okay, I mean in both cases the max value is x somehow, right? So now to detect this particular error else part, now you see if I have one test case like this, x is equal to 3 and y is equal to 2. If I take like this, so this is one test case. Okay, now just tell me when I give x is equal to 3 and y is equal to 2, what will be the output? Max is equal to how much? Can anyone tell me max is equal to how much?
3, sir.
Max is equal to 3. Okay, fine. Now, if I give x is equal to 2 and y is equal to 3, what is the max here?
Same, sir. 3.
Max is equal to
3.
3. You are saying 3. No, check it again. Check again the program. If x is
2,
equal
sir.
to
2. 2, sir.
max is equal to 2. Now that means here is the error, right? Here is the error. Now if you take both the test cases, x is equal to 3 and y is equal to 2, it will check this particular code, which one? True part. And if x is equal to 2 and y is equal to 3, so now it is going into the else part. That means we have checked both the codes, right? Now you can identify that here is the error because this portion is not giving actually accurate result. So x is not a greater than y, right? Actually, so that means maximum should not be 2. So it should be 3. It should be y. Okay, that means there is a error. Now, when you run this test suite means these are the test cases. So you have two test cases here, right? So it can detect the error. Now go to the next test suite. Okay, below that. Now you see here first test case is x is equal to 3 and y is equal to 2. I have taken. Okay. So what will the max? Max is 3. Okay, it is fine. Now if I say x is equal to 4, y is equal to 3, what is the max value here? Can you anyone tell me?
4, sir.
What is the 4? Okay. Now if x is equal to 5, y is equal to 1, what is the max value here?
5, sir.
5. Okay. That means, so here you have taken the test cases in such a way that these test cases only this also giving you the maximum value, correct thing. Okay, this code is also tested. Your code whatever you have written, by taking these test cases we found that there is no error because x is a maximum value here always, right? X is equal to 3, x is equal to 4, x is equal to 5. These are all maximum in all those test cases. Now but still there is a error left. Okay, why? Because the else part is not checked here. Else part is not checked here. Now you have taken the test cases in such a way that, so always it is checking the true part. It is never checked the else part. Okay, now what is happening? So that means the error that is there in the else part. Okay, so actually we unable to detect that. Okay, because we have written the test cases in such a way that it always tests the true part only. So never it has gone to the else part. That means so you see now in the first test suite you have only how many test cases? Only two test cases, but it detects the error. But here you have more number of test cases because you have seen there are three test cases, but you are able to only you have not in a position to detect this particular error, right? So that means if you have more number of test cases, it cannot ensure that you always get the error free code. Okay, I mean you have detected all the errors, you cannot say that. Okay, but you have to take that, you have to select the test cases that in such a way that it should cover all of the code. Okay, all of the code, and then only you can able to see. So that means you need to select the test cases very carefully. That is what really required. So you need to, the test suite should be carefully designed rather than picked randomly. If you pick randomly, so probably it won't work. Okay, now you see so the second test case, out of this second test case, you see, so there are test suite. In the second test suite you can see there are three test cases. Now you can pick any one test case, that is enough. Okay, so that is the reason why what happened. So in the first test suit, x is equal to 3 and y is equal to 2, this is the test case taken from the second test suit. Okay, so that means you should select the test cases in such a way that that should be a representative for all of similar test cases. Okay, that should be a representative for all of other test cases. Okay, so that means either you see x is equal to 3, y is equal to 2, that test case take, or you take x is equal to 4, y is equal to 3, that is okay. Or you take x is equal to 5, y is equal to 1. This test case can be taken. Okay, so it is good enough, right? One can be taken out of all these three, because it always tests the x is equal to x is greater than y condition. As a result, you will be able to check the code within the true part. Okay, now similarly you need to take one else part के लिए भी you should take the x and y value in such a way that so it should go to else part, then only you will be able to detect the error, right? So if you cannot take this test case, then you cannot test the else part. That is what. Okay, so this is the reason why you need to choose the test cases very carefully. Okay, now the domain input data values is either extremely large or currently countably infinite. Sometimes, as I told you, so the input data that you need to test on the program, so that sometimes may be very extremely large, or sometimes it is very countably infinite. Therefore, to satisfactorily test a software within minimum cost and can design a minimal test suite to uncover as many as existing errors, right? So that means, because you see, if you have taken infinite number of test cases, then what will happen? So you will take infinite amount of time, and for which you require more money. So it is impossible. As a result, what you need to do? You should design the test cases in such a way that that should cover as many as number of errors. Okay, so a minimal test suite is carefully designed set of test cases such that each test case helps detect different errors. That means each and every test case should always should detect a kind of error. Okay, it should happen. This is in contrast to testing using some random input values, right? So that means instead of taking random input values, so you should always take the test cases in such a way that it should cover as many as number of errors. Okay, essentially two main approach to systematically design test cases. Now, so there are to design the test cases, so we have two different approaches. Okay, so one is black box approach, the other one is white box, or sometimes we call as glass box. Okay, white box means so here I mean glass is also a transparent one, right? So white is transparent, black is not transparent, right? So that is the reason why sometimes glass box also, the other name for white box. Okay, so now in black box approach, the test cases are designed using only functional specification of the software, right? So that means here only the test cases will be designed based upon the kind of input that you are giving to the software. That means based upon its functional specification, right? For each and every function, you have given the some specification, right? So when you say functional specification, that means what? So you specifying the function only, right? So what is the input a particular function is going to take, and what is the output it is going to give, right? That means you are not you are not designing the test cases based on its internal details or its internal implementations. So we are not taking into account at this point of time. Here what we take, we design the test cases just based upon the input output behavior. Okay, so that means the test cases are designed based on an analysis of the input output behavior and does not require any knowledge of the internal structure of a program. So black box means, so it is not transparent. That means you cannot see internal code of that particular function. Only what you know is, so you have a function known for that particular function, the specifications are like this. So these are the inputs will be given to the function, and this is what exactly the output expected from the function. Okay, so that's one, that is only, right? So with that information you try to design the test cases. Okay, so a black box testing is also known as functional testing because it is based upon the functional specification, right? So designing white box test cases requires a thorough knowledge of the internal structure of a program. When you want to go through design white box test cases, so one has to has first knowledge of internal structure of a program. That means we should know how that particular function is implemented. Okay, so if unless or until those internal information is known to you, you will not be able to design the white box test cases. So that is the reason why white box is also known as structural testing. Okay, so they are also known as structural testing because you will have to know the structure of the program. Okay, so these two test case design are complementary to each other. Okay, so that means it is not that you should not always think that one is a substitute of the other. It is not like this. Okay, so you need to have the functional testing as or the black box testing. At the same time, you need to have white box testing or the structural testing. So they are both complementary to each other, right? You should use both of them. That is what we say. If you have structural testing along with the functional testing, that means it helps you in understanding or developing. Let's say you have a functional testing carried out or the black box testing is carried out, then it will help you in developing better structural testing. Similarly, if you have a structural testing already developed, then if you go for the functional testing, it will be useful while designing the functional testing. That is what we say. So they are complementary to each other. So testing in the large versus testing in the small. So what it is all? What is this testing in the large? So unit testing is referred to as a testing in the small because once the piece of code is developed, so we try to test that. Okay, whereas integration and system testing are referred to as the testing in the large because you understand, right? So small piece you are testing, so that is the reason why testing in the small. Okay, so that's the unit testing. But whereas integration, so usually you will be integrating many such small pieces together and then you try to test them, right? And as part of system testing, all of the piece of codes whatever developed for the system, so they all will be integrated and then those things will be tested, right? So that is what referred to as a testing in the large, right? So then one question it will come to everyone, that there are two reasons for not testing the integrated set of modules once thoroughly. So then why one should test individually first? Why not it can be thoroughly tested once all of the modules are integrated? So why you first individually testing and then partially you integrate them, right? During integration, what you do? So few of these, you go through some integration plan and then accordingly you try to integrate them and then you test them. And finally, at once all of these modules are ready, then you try to integrate all of them once again, and then you finally you test, right? So then why this way being done? Okay, why not once once all of the modules are ready, once all of the modules are integrated, why not we test thoroughly once? Why we are going through so many times? So what is the reason? So that is what the question, right? So while testing a module, other modules with which this module needs to interface may not be ready. Okay, so this makes debugging easier. Okay, so that means let's say if you're working on a simple piece of code, so you will be able to debug whenever you find an error in that particular module, right, it is easier for us to find out what is the error there itself, because it is not interfaced with the other modules, because other modules are not yet developed. Okay, so let's say you have developed only the first module, okay, and then you tested that first module. But if you develop the first module and second module, now if you integrated them and then you have tested, then what will happen? If let's say error is in module 1, first module, the error is in first module, right? But when you are integrated the when you integrated, and then when you try to find out the error, where that particular error is, when you try to locate that particular error, that is what debugging means, locating the error, right? So during locating that error, what will happen? So you have two modules ready, but the error is in first module only. Okay, so what you are trying to do? So you will have to go through all the way for first for the module B, and then you going into module A. So rather check in this way. So why not, if you have developed a first module, then you test there itself. Okay, so see if whether is there, if there is any error, then you find out. And you locate, I mean, you can easily locate, you can easily debug that particular module. That is what we say. So if a failure is detected when an integrated set of modules is being tested, it would be difficult to determine which module exactly has the error. Now, so that is the difficulty, right? So when you compile that particular, after integrating all of the module, once you try, if you get any error after compiling that program, right? If you find any error, so then it is very difficult to debug where that particular error is. Locating that particular error is a difficult task. So that is the reason why it's better that you always unit test it. Okay. So always the code should be unit tested. So then only you will be able to get this benefit, right? So unit testing is carried out in the coding phase itself as soon as the coding of the module is done. So in the integration system testing are carried out during the testing phase. That is what I say. So during coding only you can test your pieces, whatever you have developed, right? But your integration system testing, they will be usually carried out during system testing phase. That means, so all of the code is developed, then only you are testing, right? So now the thing here is, so you carrying some testing in the large and you carrying testing in the smaller. So both the things that you are doing, because these are complementary to each other, right? So unit testing is undertaken after a module has been coded and reviewed. That is what. So code review has been done, carried out once the code is developed, and then you carry out your unit testing, right? So through review, you first try to find out whatever the possibly errors that can be, that can be easily identified once if you review the code. So then you try to detect those errors there, right? And after code review, finally you going and testing. You will try to apply your test cases to see whether the piece of code that you developed is correct or not. I mean, that is meeting the requirement or not. Okay, for that particular requirement. Okay, so typically undertaken by the coder of the module himself in the coding phase. So this is what carried out by the coder itself. Okay, whoever developed the code, he will go through that and he will try to find out the error there itself. Before carrying out unit testing, so the unit test cases have to be designed and test environment for the unit under test has to be developed. Right. So when you are going through any unit testing also, so you should have prior to apply those unit test cases. I mean test cases in the unit testing. Okay. So first you need to create some sort of environment for testing, right? So now what is that environment we will talk about? Okay. So here the environment means you need to have some sort of driver and stub modules. Okay, you need to have in order to run your test cases. Okay, whatever you have developed uh, during this unit testing phase, right? So as part of that, first you need to create some driver and stub modules. Okay, so to test a single module, we need a complete environment to provide all relevant code that is necessary for execution of the module. Let's say, so you have developed only one module, right? Now you have developed one module, right? So now the rest of the module that you are going to develop, they have not been developed yet. Okay, so let's say you need to develop A, B, C, D, E, F, G. Let's say A, B, C, three modules you need to develop as part of your system, right? So now only you have developed A module, right? So that means B module and C modules, they have not developed, okay, yet. So now when you are running a module, right? When you are running a module, so I mean, you can think of something like this. If a module is going to talk, going to call B and C module, let's say, okay, but these modules are not yet developed. Okay, these modules are not yet developed, right? So that means now there should be, some dummy functions. Okay, there should be some dummy functions or the dummy modules, so to which this particular a module should call. Okay, otherwise how can it will see how it will, because when you test the module A, right, and there are some interfaces. Okay, that interfaces means through those interfaces it may be going to call module B and C, but B and C yet they have not been developed. Okay, yet they have not been developed, right? Now then how will you, I mean, test your this a module? That means you need some dummy modules, right? So that is what we call as the driver and stub. So these are the two dummy modules actually. So we'll come to know that what is driver and what is stub. Okay, so these are the modules you can think of like this. So let's say particular is part of a module A. Okay, so there are, let's say, three functions. Okay, there are three functions, right? Now you have, you have three different functions, that is fine, but unless or until those functions are called by some other function, you will not be able to check the interfaces, right? Or this function, unless or until this function, if this function is not going to call any other functions of any other module, then also it is not fully, I mean, our testing is not complete, right? So but as I told you, so you have only developed the coding, you coded only module A, but module B and C is not yet done. Okay, so then how are you going to call the other functions? Then those functions should be a dummy functions. You have to create some dummy modules, right? That means the internal implementations of those functions will not be there. Only what it will be there is some dummy function. Okay, so what is that? We'll talk about that. Okay, so now the following are needed to test the module. Let's say the procedure belonging to other modules, that module under test calls, right? So that means whatever the module we are going to test, okay, you are going to unit test, right? And if that is the module going to call to the procedures of other modules, right? So then, so how you will be going to do that? Okay, that is the question, because those modules are, I mean, those procedures belonging to other modules, they have not been developed yet. Now then how you going to call them, right? So that is what. So non-local data structures that the module access. Okay, so sometimes I mean, non-local data structure means there are some let's say there are some global data structure that are there. So and that global data structure need to be they need to be accessed by this particular module, right? So then, so that should be created. So that global data structure should be created somehow, right? If that is not created yet, then probably the module that you wanted to test, so you cannot test, because that is going to use some global data. That means it is not going to use only the local data, but also it is going to use some non-local data structures, right? So that, but that should be created. Then only you will be able to test this. A procedure to call functions of a module and a test with appropriate parameters, right? So like as I told you, so this particular module has certain number of functions, but there should be some procedure which can call to its functions. Then only you will be able to know that whether things are going fine or not. Okay, then only you can say that whether things are going fine or not, right? So that is what exactly happened. Right. So now then, so this is what exactly about, I mean, environment. Okay. So environment means, so whenever you trying to test a particular module, right? First thing that you need to see, you know, to which other functions it is going to call. So they should be created first. That means they should be the dummy ones, because you have not decided to implement those functions yet, but instead you need to provide dummy functions, right? And any global data structure required by this particular module, so that should also be created. Okay, otherwise you will not be able to test. And the third thing is that, so I mean, this particular module you are going to test. Now as part of this module there are certain number of functions. Now first thing is that you need to have some dummy functions which can call these functions. Okay, so then only you will be able to test. Okay, so your functions, that is what exactly happens. So modules required to provide necessary environment are usually not available until they have been unit tested, right? So that means, as I told you, so you need to have a very necessary environment you need to create, then only you will be able to test, otherwise you will not be able to test them, right? Because so as I told you like this, right? Stubs and drivers are designed to provide the complete environment for a module so that the testing can be carried out. So these should be created fast, right? But as of now, I have not talked about, there is a little difference. So we'll talk about that. I mean, how these stubs and drivers are different from each other. So a stub procedure is a dummy procedure. That means it's a dummy function that has the same input output parameters as the function called by the unit under test, but has a highly simplified behavior. Okay, that means, let's say you as part of the module A, let's say there is a function which is going to call like a function called some something like this. Okay, so, some function is there. Okay, a function with a name sum, and which takes two arguments a and b. Okay, now this is going to call, maybe you can think of like this. So that is, there is another, you have some dummy function. Okay, and that dummy function, what it will do is, basically it will do like this. So I mean, it is not going to implement that some function. That means implementation means what? So you will have something, you will write some code inside that some function, right? C is equal to a plus b, and then return c. Okay, this is the implementation of sum. When a and b is given, so c is equal to a plus b, that you will write a logic, and then that means a and b will be added to give you the result c, right? And that c value will be returned, right? But now what we try to do is, you will not do that. Okay, so I mean, we are not going to implement that code. Instead, what we will try to do is, we will see, you will think that, your this original function, will call this sum function with a parameter 2 or 3, something like this, with a as a 2 and 3, b as a 3. Now this function will return 5. So I mean, there will not be no implementations, right? So only what it will have is something, it will return 5 always. Okay, directly. Do understand? That means you have not written c is equal to a plus b sort of and return c. This is not written. Only what you are going to return, you will return 5. Okay. You can think of, or you can simply have C is equal to 5 and it is going to return C. Okay, that means you are not going to implement that. So it will be a only dummy function. It will have a very simplified behavior, right? So driver module should contain non-local data structures, okay, assessed by the module under test. So usually whenever you have some global data structures, right? So those global data structures will be written part of drivers, okay, written part of drivers, right? So drivers, non-local data structure should not be written part of stubs. That is the difference you need to understand. So why it is happening like this, you will come to know this, okay, in the next slide. Additionally, it should also have the code to call the different functions of the unit under test. So it can also call the functions of module under test, okay, with some appropriate parameters. That means, so driver means, so these are the functions written to call the functions under test, as well as it is going to provide you all the global data structure or non-local data structure. Okay, so that means it always follows. So it will be something like this. Module under test is there. So you have a drivers at the top and you have a stubs at the bottom, right? So when you go through, I mean, global data structure and all function calls will be done by the drivers, right? And stubs will, so stubs will have the functions, module under test, whatever the functions it has to call other functions. So those functions will be part of the stub. Okay. So that means you can think of, so driver will be applied when you going through top down approach. Okay. And stubs are the ones will be used when you are going through bottom up approach. Do you understand? Let's say the top down approach means what? So A and A will be divided into BC and B will be divided into CD, or DE and EF. Let's say like this, you have a tree, right? So what will happen here is, now let's say you are going through a bottom up approach like this. So you have first developed the leaf nodes. First you have developed the code for the leaf nodes, right? Now when you have the leaf nodes developed first, then what you really require, you need uh, you need the modules with dummy features available in its parent, okay, that means, so because you see DE, let's say A B C D F G, let's say you have, okay, so now DE you have developed code, FG you have developed code, but your B and C not yet developed. Okay, B and C is not yet developed because you are following bottom up approach, right? First you have leaf nodes. Okay, now your parent is not ready. So then what you need some drivers, because drivers can call these leaf nodes because they have they can have a there you have the dummy function within the driver and they can call, right? They can call. Now similarly, that can also have the global data structure also available with those drivers, right? So that these are all leaf nodes can access them, right? Do you understand? This is the reason why. So when you going through bottom up approach, so you will have drivers required. When you going from top down approach, then you have stubs, because stubs, let's say you first you going through the top down approach. That means what? You have a module already implemented, but B and C is not yet implemented, right? And then in that case, what will happen? So in the module A, there are some methods or the functions, okay, or the processings. They are going to call some of the functions of B and C, okay, some of the functions of module B and C. Now those functions are not ready. That means you need to have stubs in place. Okay, then only the functions under the test should be able to be successfully tested. Okay, otherwise you will not be able to test them successfully. So that is the, so when you're going through bottom up approach, you need drivers. When you're going from the top down approach, you require stubs. So that is only the difference that you need to know. Okay. But otherwise they are the both the dumb thing. They are both are what you say, dummy functions. Okay. Now test cases are designed, so that is what exactly we have about the unit testing, right? So as part of this, you have black box testing, right? So the test cases are designed from examination of the what input output values only, no knowledge of design or code is required, right? So when you are talking about black box, I told you it's a functional testing, right? So that means internal things will not be known to us. Only what will be known to us is only the functional behavior. Okay, input output behavior. That means what when you give some input to the system, it is going to give some sort of output that is only known to us. Okay, so within that you will be trying to design the test cases, right? So under this black box testing, so we'll see something called equivalence class testing, class partitioning, and then you have something called you will talk about that. The other one here is the boundary value analysis. So these are the two techniques under this black box testing, right? So first we'll talk about what is the equivalent class parceling. So you have the domain of input values to the program under test is partitioned into a set of equivalence classes, right? So whatever the input values that will be given to the program which is under test, okay, so that will be those domain input values will be partitioned. I mean, you will be partitioning them into some different classes. Let's say you have a large input data and that will be that will be that will be partitioned into different classes. Now you can think of clustering and all, right? You have a set of input data and you will try to cluster them into different classes, right? So similarly here is also we do like this, okay? And the partitioning is done such that every input data belonging to the same equivalence class and the program behaves similarly, right? So once the partitioning is that, okay, partitioning is that, then you can see, so part of a particular class, so every input data belonging to that particular class will behave the similarly, right? It is what, right? That is the reason why you try to find a class, equivalent class, right? So that means, so and then what you need to do, what you will do, you will take one representative from each of the classes. Okay, you try to find one input data from each of the class, and then you will be going to test. That is what we try to do as part of equivalence class partitioning. The main idea behind defining equivalent classes of input data is that testing the code with any value belonging to an equivalence class is as good as testing the code with any other value belonging to the same equivalence class. That means, so what we're trying to say is, let's say you have partitioned all the input data into different classes, right? And from a particular equivalence class, you will take one input value, okay, input data. Because if you take two input data from each class, what will happen? So ultimately they are the same. So they going to test the same behavior, right? So they try to find only similar kind of defects, right? So that is the reason why you always pick any one out of those equivalence class, right? So we'll see one example, so then you will be able to understand. Thereafter we'll stop. So general guidelines for designing equivalence classes. Let's say, for example, if the input data value to a system can be specified by a range of values, then one valid and two invalid equivalence class need to be defined. Okay, so that means whenever you have some input data value to a system specified within a particular range of value, so in that case, so you will get one valid and two invalid equivalence classes. Now you can see how you will have invalid and valid. You will see if the equivalence class is the set of integers in the range 1 and 10. Okay, so let's say, So you have the data range that is 1 to 10. And, so then what will happen? So you will have something like this. Okay, so this is let's say 1 to 10 is a you say valid equivalence, valid one. Let's say the range will be it is the valid class. Okay, so this is one it is valid equivalence class. 1 to 10 is a one valid equivalence class. Now for which you will have how many invalid equivalence classes? Two invalid equivalence classes. How? So minus infinity to 0. Okay, that will be any value you are going to take from minus infinity to 0. That will be one class. Okay, I mean negative values. And more than 10, that means 11 to plus positive, I mean plus infinity positive value more than. So that means you wanted to test the input value on range between 1 to 10. Okay, so then you have three different equivalence classes will be possible in this case. How? So one is minus infinity to 0, that is one range. Okay, so that is one invalid class. And 11 to plus infinity is also one invalid. Okay, if you give more than 10, that is also invalid. If you give less than minus 1, less than 1, that is also invalid. And you have a valid one here is a 1 to 10. That means here you have three different classes. Now, similarly, you can think of another example. If the input data assumes values from a set of discrete members of some domain. In the previous case, it was continuous. Okay, because 1 to 10 means it is a continuous range, right? But now here you have a discrete values, right? So you have some discrete values, right? In that case, so then one equivalence class for valid input values, another equivalence class for invalid input values. That is what. So if it is a discrete range, then in that case you will have two sets, two equivalence classes. But if it is a continuous, then you will have three equivalence classes. Now here how the example, let's say you have a valid equivalence class is A, B, C. So A, B, C, because they are the discrete values, A1, or you can say 1, 2, 3. They may be three discrete values. That means here you do not have a range of values, right? 1, 2, 3 or something like that. Okay. So here if you have a discrete values like A, B, C, then what will be the invalid class? Invalid class will be inverse minus A, B, C. So other than ABC will be the invalid. That is what. Okay. So that means here you have a two invalid classes. Okay. So this is the way that you will have to create equivalence classes, right? So another example you can see for example, a software compute the square root of integer that can assume values in the range 0 to 5000. So then what will be the equivalences classes for the Blackboard test? So how you will get this? So how you get this two test suite? So you will have three equivalence classes. How many? One equivalence class is minus 1 to minus infinity. Other one is 5001 to plus infinity, and then you have 0 to 5000. So that is the reason. So I mean from the negative equivalence class you have taken one input value, that is randomly minus 2, and 0 to 5000 in between you take one value. Okay, that is a 400. Now another value will be taken which is greater than 5000, that is 8000. So I have taken one 8000. So this way you create a test suite. Okay, clear? Any doubts of our student here in this case? Any doubt? Students, can you hear me?
Yes, sir.
Yes,
No
sir,
doubt.
no doubt.
Okay, right. So I stop here. Maybe I will continue with the other topics in the next lecture. Right. I try to stop here.